Hello, welcome to the QnA Tech School. I'm your host, Jonathan Kyle Hobson. This show is presented by Qonda Entertainment. Today we're going to talk about 3D printing. Okay, today here is Chris Dashton. He's joining us. Am I saying your name right?
You got it.
Yes. Okay, cool. He's joining us from Stax 3D. Chris, can you tell us a little bit about Stax 3D and where we can find it?
Absolutely. So Stax 3D is a 3D technologies company and educational robotics. Kind of a one-stop shop for all things 3D and educational robotics. We're located in two locations, Chandler Mall, as well as our Gilbert Business Center at roughly Stapley and Baseline. And then our kiosk for full body scanning is inside the Chandler Mall.
Perfect. Can you tell us anything about your website or what services you do?
Yeah, so we have a lot of services and products we have available, from a very high-end 3D scanning and printing technology and 3D modeling software to the bare bones basics of what you need to get started if you're just starting out. So whether you're in kindergarten or you're a major business or institution, there's something we've got for you in the realm of 3D modeling, scanning, printing, and robotics.
Oh, great. Okay, so we're going to go on here and... Okay, so we're broadcasting today live at the Mesa ThinkSpot. The ThinkSpot is a great resource. They offer so many things. They're at the Red Mountain Mesa Library. That's where we're recording from, right there. And they also have 3D printers. They're free to use if you have to take a training class, which is also free. But the material costs 5 cents a gram, which is very reasonable. So that's come. We accept questions on social media and in person. So please submit questions before, during, or after the show. So today's subject, as we already briefly talked about, is 3D printing, the 3D world of 3D printing. We're going to talk about 3D designing, we're going to talk about 3D scanners. We're going to go really in depth. We're going to talk about how they work and the future of 3D printing, because I think it's really promising.
Very exciting stuff. You guys will be blown away.
Perfect. Now let's get going then. So here we go. So we're going to talk briefly about what is 3D printing.
Yeah, good question. So 3D printing is an additive manufacturing process. So subtractive manufacturing, many people are familiar with CNC mills that essentially take a block of material and subtract out of it. They drill out of it, route out of it. 3D printing, on the other hand, starts with usually, most commonly, a spool of material or some sort of tank, and then it will use that, melt it down, in the case of a spool, and add layer by layer until it becomes a solid 3D object. So it's only using as much material as you need instead of subtracting from a block with extra waste.
Exactly. And so as you can see on the screen, I have a time lapse of a 3D printed object that I did. This one was 3D printed in glow-in-dark material,
Awesome.
Which is really cool. And so there's all sorts of materials, and we'll definitely get into more detail about the different materials you can use, which is a wide variety. And here's a little Olaf here. We got a little cricket. And so you can see you can get really detailed, definitely depending on the quality of your 3D printing, you can get pretty detailed, right?
Absolutely.
And you got this little jack-o'-lantern guy. Okay, so let's go on to more detail about the 3D printing. Okay, so here we have some little infographics that are going to go through as we're talking about how a 3D printer works. So, Chris, how does a 3D printer basically work?
Well, most people are familiar with the kind right now that are built in layers using plastic, many different colors and a lot of exotic materials out there too. So I'll talk about the basic stuff first, and then we'll go into some of the really interesting and new use cases. Some 3D printing most people are familiar with is using PLA or ABS plastics. PLA, polylactic acid, is a biodegradable plastic. Usually takes, if you were to try and biodegrade it, it would take about 5 days at a consistent temperature of 120 degrees. So it's not going to compost that easily, in a flower plot in your backyard. But if you're using something like an industrial composter, you can actually get this material composted.
Is there more organic material you can print with?
Yeah, there's even specialized like bio-PLA that certain companies are using that biodegrade faster, but all of them in the end are used from like a cornstarch derivative. So PLA and ABS, most common types, kind of uses the same mechanics a hot glue gun does. You have solid material, and then once it's going through a channel with heat, intensely heats it to a point where it's almost molten. And in this pliable state, it can be laid down with the movements of the 3D printer, side to side, back and forth, up and down. right? Your XYZ coordinates, 3D. So as it's doing those movements, it's already sliced it up into every single layer, understanding where it needs to spit out that plastic, what temperature it needs to be depending on the type, the brand, the color, the exotic materials embedded in it, and then it will continuously lay it down until it's finished. Now it's interesting to see the inside of these 3D printed objects as well. It's not going to be a totally solid plastic piece most of the time, right? You're going to see oftentimes a honeycomb pattern or a grid style pattern or a triangular pattern on the inside. It's called infill. And infill allows us to only use as much material as is necessary.
To save money and
Exactly.
resources.
And also weight too a lot of the time, right? You feel this, and if it was totally solid, it'd weigh quite a bit more.
Yeah.
So, you're saving material, and sometimes you can even get some very interesting visual effects. MakerBot has some interesting silly infill settings like cat fill and shark fill and Moroccan star. So you can even get creative with how you're doing this and how you're utilizing it.
Okay. Well, are there like certain kinds of materials that you would want when you're making like certain products?
Yes.
So like over others?
Right. So of the PLA and ABS, most people are using PLA for general purposes, right? You might not need it to be incredibly durable or flexible. So that's great for all-around use. It's also very affordable. Same with ABS for the most part, except ABS has a bit better impact resistance. So if you're going to be using it every day, you might prefer to do that. And as well, when you're bending it, it's not going to actually crack much like PLA normally would.
So it's more like rubber, or
not quite, but it's got more flexibility for sure.
Okay.
If you've ever had the misfortune of stepping on a Lego brick, you may find that it will have a stress bend and it'll get white at the crease mark where it's bending. So ABS kind of does that instead of just straight braking.
And then can you print in like more intense materials like steel or gold or?
Absolutely. So once you say you need more durable materials than this, within this technology, there's still many more durable materials. For instance, I made my phone case here out of a material called onyx from Mark Forged. This material is actually microcarbon and nylon combined. So you get some pretty tough stuff, and you can infuse it too with things like carbon fiber, or this nylon carabiner I've made with the same printer has some Kevlar built into it.
Okay.
Right, what bulletproof vests are made from, so that it can actually be.
And the 3D printer did that itself, like it printed that material.
It had two heads, so one of the heads printed the nylon, and it uses what's called CFF, composite filament fabrication, just another nozzle specifically made to lay this composite filament down, whether it's carbon fiber or Kevlar. But once you go from this method to metal, then you're talking about processes like selective laser melting and selective laser sintering, or direct metal laser sintering, where you get really tough parts ready to go in either an aerospace project like the shuttle, or something that may be produced in a 3D printer that has been medically graded with argon, so that once you take it out of the printer, you just autoclave it and it's ready to go into surgery. So whether it's a hip, a jaw, or a sternum, you can actually have robust metal parts come out of a printer that are ready for surgery or being blasted off into space.
Can you, I don't know if people would want to eat it, but could you print food?
Yeah, actually, there's a lot of interesting things going on right now in that field. They started kind of small and with things like chocolate and sugar, where it's heating the sugar and caramelizing it. And chocolate has gotten some success, even gummy. And now they're working with some more complicated things. They're using paste extruders for things like pancakes, muffins, pancakes, other types of cakes. So they're going now to actually culturing food in the lab, right? We've seen some of those experiments. I imagine pretty soon you get that onto a 3D printer that uses biomaterials.
Yeah.
And like people say, you're going to be able to ask your smartphone to cook you a steak, and by the time you get home, you're going to be able to have it waiting.
It's all printed out and ready.
Right, and totally out of organic material that's not come from real livestock. So that's kind of exciting things. Maybe we'll talk a little bit more about future implications of that.
And I know like NASA uses, that's really important to NASA, because for long distance travel,
right?
Jet
fuel costs a lot of money.
Yeah, exactly.
So you want to make sure whatever you bring up to the space station, you can reuse it or repurpose it as many times as possible. So you get an object, you print it in the space station. Once you're done using it for whatever its function, grind it back down to the raw materials and spit back out your next tool.
Yeah, and I heard that like astronauts love that, because previously they're getting like these dried, freezed food that's like doesn't taste very good, and you got to add water to it.
Yeah.
But now you can get like really nice ingredients
right
in like really compact space. And
I remember watching Rocket Man, and he was eating food out of toothpaste tubes. So I imagine you get that kind of actual food, hopefully tasting better.
Yeah.
Right, and then you get it onto a space station 3D printer, and you've got, whether it's tools or food, the ability to make whatever you want there.
Exactly.
Right.
Well, I went ahead and moved us on to uses for 3D printers because we started talking about that.
So many of
But
them.
is there anything else we missed with how a 3D printer works? Any other topics there?
Well, there's a lot of different styles. That's one thing that should be known. This is called FDM, fused deposition modeling, or sometimes also referred to as fused filament fabrication, right? Thermoplastics, hot plastic, layering it layer by layer. And there's many other types.
How does the 3D printer know what the object to print? Like, how does it get its information from a computer? Or?
Yeah, so a lot of the time you've either downloaded a free file from places like thingiverse.com, and then you upload it into a slicing software, which is the middleman between a 3D printer and your CAD software and a 3D printer. So say we download this pumpkin from the internet. Then we need to put it into a slicing program that's going to say, all right, I need to spit out this much material at this temperature and in this shape.
Okay.
And that's called G-code, and there's other flavors of that G-code. But then that's what you actually send to the printer, oftentimes on an SD card, thumb drive, or Wi-Fi.
Oh, whoa. So as we're seeing, as we're talking about this, our audience is seeing all these different kind of things they can print out.
Yeah.
And like some of these things are really amazing. Like you said before, they can print out bones to help like bones grow. Like
Absolutely.
I don't know. What do you know how they do that or what they're using those
so
for?
some of the medical applications that are revolutionary, when you're printing scaffolding for cartilage, let's say it's surgery for an ear, maybe a burn victim or someone that was born with a deformed ear or nose. You can take a mirror image of their good ear, let's say. You can print out a 3D scaffolding of biomaterials, and then you actually use the same cells this person has. So there's no room for rejection of those cells. So you 3D print the shape of their good ear, you implant it, and then it grows with skin grafts. So you've got the ability with cartilage and flesh and skin, and then bones. You're seeing people actually get knee replacements that are made of titanium that has been 3D printed. Recently, the first sternum replacement was done, implanted. So they're getting very advanced in what they're able to do. And there's a lot in the realm of prosthetics, of course.
Yeah, exactly. They're seeing that in their prosthetic legs.
Yes.
And that makes a lot of sense because you can just quickly print out a custom leg for that person.
Yeah, so we're talking to people right now in the Valley that are actually getting involved with this. They'd like to make, sort of same-day clinics, ideally. You go in, say you need a new prosthetic limb, you would be able to get a scan of your remaining tissue with a handheld scanner. You get really good high-quality data, and then a specialist will model a fitting for you, the adaptation. And then you can, take your pick, a la carte, what kind of style and also what materials you want. An Olympic runner might want something a little different than someone that's a fashion designer.
Exactly.
So you've got the ability to use 3D printing technology.
Especially with like the hands.
Yeah.
Because like when we have some pictures of it, but also when I was doing research, there were some pretty unique hands that even kids were doing.
Like Frozen and Iron Man.
Yeah, exactly.
Yeah, so you can imagine from what used to be a stigma of having to feel like you're disabled now feels like a superpower.
Yeah.
And you can feel really emboldened to say, this isn't a handicap anymore. This is something I really find cool, interesting, and useful.
There was that rock climber a few years ago in the news, who used the disadvantage of not having limbs, and he like installed hooks, and now he's like this crazy climber.
That's a good point, because we're seeing this mass customization of needs, and this technology lends itself very well to that. If I'm going to start rock climbing, maybe I want to make myself some special gloves that help grip every surface I'm going to be on.
Yeah.
You get to play with these ideas and say, what am I trying to do? What do I want? And then you actually get to make it happen.
Exactly. And we're not suggesting that anybody goes out and cuts off their limb for the technology.
No, but I will say, if that ends up happening at work, I'll be the poster child happily. And Luke Skywalker's, prosthetic is basically real life today.
Oh, whoa, that's cool. And so you also saw like clothes, like ties.
Yes, right.
Can you do like shirts? I read a little bit about that, but I couldn't find much.
What we're looking at now is kind of, as you may see some of the examples, it's like a chainmail pattern, right?
Okay.
And you can actually print it all already connected.
Yeah.
So in our Chandler retail storefront, we've actually got an entirely 3D printed dress
from
3D Systems. You can see it on display on the mannequin in the window, and it's that chainmail pattern. Right, so you're able to interlink these and they come out in one solid pattern that's already ready to be formed over. So you can program someone's body metrics in, have an algorithm lay out how it needs to be printed, and then the printer will have it come out custom fit, tailor fit to them.
That's really cool. And then also, we know that like I think doctors are starting to use like 3D printed hearts to practice with surgery to like remove tumors or cancer.
Even happening, locally at Phoenix Children's Hospital, this kind of technology is seeping in. you can 3D print a flexible heart of,
Yeah.
a pediatric surgeon wants to be able to practice and know as much as they can about a high-risk surgery before they go in. So they'll 3D print that heart, practice the surgery, and then be able to be that much more confident and knowledgeable about every little muscle memory movement that needs to happen.
Have you seen the show Pure Genius?
I've
It's a
heard of it, yeah.
brand new show, and they in the first episode they were 3D printing hearts.
Yeah.
They 3D printed models of the employees that work there, and so that was really cool.
Yeah, you're seeing crazy medical applications. We're talking to different universities like Midwestern, saying, for instance, in anatomy, you want to be able to teach the heart, you want to be able to teach different complex organs.
Yeah.
You can make full color 3D printed models that display different areas. And then you can customize them if it's related to a specific patient, maybe where a tumor is located, you highlight it. So it's got a lot of uses, and it's having an incredible life-saving effect right
Exactly.
now.
And this stuff is here now. Like, I mean, people on that show were commenting, like, this stuff is too futuristic and stuff like that, and not realistic, but it is realistic.
It's already happening. Yeah,
exactly.
Yeah.
Okay, so let's move on to our next shot here. Okay, so we have 3D designing. So there's all different kinds of software available out there. I mean, like back in 2010, like 10 years ago, there was nothing out there. You had to no coding, very bulky. But nowadays, there's free software. You can use Google SketchUp, which has been around for a long time. But now it's finally able to really do 3D modeling. And then there's Autodesk and 123D. Can you talk a little bit about these different programs? What's your favorite?
Right. Well, every person learns kind of on their own path. So when I was going to school at Arizona State University, I was taught Rhino, a particular program that has most common uses in things like automotive engineering, jewelry, animation, and all around organic geometry. So I practiced with that. I learned that as my CAD modeling software of choice. And then I moved on to learning some other things, like now I'm getting into Blender, which is a great free program at blender.org to be able to download something that's both capable of manipulating complex physics simulations all the way to game animation and video animation and general 3D modeling for printing. So it's a really good all-around free platform. But if you're looking for something more simple, just as you're getting started, we always recommend, and we even teach, programs like tinkercad.com.
Okay.
Yeah, so this is
I've heard of that.
Right?
Yeah.
It's super easy. It's basically you're learning the very general basics of, how do I scale something? How do I cut it in half? How do I model Olaf here with different geometrical shapes and combine them, or use a circle to subtract out of another shape. Very simple.
And they're really cool too, because you can take someone else's 3D design and put it into Tinkercad, and then you can manipulate it and start off from something that's already been created.
Exactly.
And so it's a good learning tool because you can see how that was made and the building blocks
and
of
you
it.
add onto it, you riff onto it, and just like in coding, you don't have to start from nothing.
Yeah.
You find, let's say I want to carve a jack-o'-lantern, I would find this file, and then I'd say, okay, now I just want to take my basic triangle to make some teeth and eyes, and you can punch it out. So I can download this file and upload it into Tinkercad, so I don't have to model an entire pumpkin. I've already got that started.
And like you said earlier, you have 10-year-olds who are doing this.
Oh yeah,
and 7-year-olds and stuff. So it's a really easy software to learn, and you can get really far with it.
Yeah, we have this package actually. We've started to market to K through 6 elementary schools. It's getting a lot of traction right now. You'll start to see it very quickly make its way through the local public school systems, and it's a $9.99 package that includes a 3D printer, as well as 4 instructional books and arts and crafts materials.
Oh, wow.
So the ages 4 to 10 can get involved.
Yeah.
Whether it's a family at home or a classroom, and people can learn Tinkercad, learn the basics of how to 3D model and 3D print, and then by the end of this book, you've actually got the basic skills to model something from scratch yourself, take something and modify it, and then 3D print it. So you imagine 5, 6, 7, 8-year-olds getting practice with this now are truly going to be innovators of the near future.
Skylar, he's a volunteer here. He goes to high school.
I've heard of him.
And he is a genius with 3D printing.
Yeah.
Whenever there's something broken in the library or something not working properly, he measures it and just makes it in the program and prints it out. He even helped me make a key for my keyboard.
Nice.
We haven't finished it yet, but he's helping me do that. So that's really cool.
I also heard he was working on a 3D scanner, a home-built scanner.
Oh, I didn't know that.
You see this kind of information become widely available, and you don't have to say to myself anymore, that's going to take 5 years for me to even get started.
Yeah.
Right? With these free softwares coming out, you can download them, or you don't even have to at tinkercad.com. and then you're able to get practice and get printing your ideas.
And with the scanners you mentioned, you don't even have to start from scratch nowadays.
Exactly.
You can get a scanner and you can
Capture.
scan in a physical object, and as far as I understand it, it turns it out into a digital model. Which do you have to do anything else with it, or can you just go directly? Okay, depends on what you're using.
Yeah. So, for example, if I'm scanning a real pumpkin to get that shape, at our work we have RTech technology, EVA and Spider. So we'd use something like RTech EVA, which is a hand scanner.
Okay.
And it has like a strobe light effect as it's scanning an object. So it's taking 15 photos every second.
Okay.
Right, from different perspectives. And it can track itself. So I scan a whole pumpkin, and then I've got a file of a pumpkin that I need to do a little post-processing digitally on. So I clean up all the extraneous extra data, and then I get it, okay, now I've just isolated my pumpkin. Maybe at that point you get to choose what do you want to do after that. And now we've got some softwares that make this process of scan to computer-aided design even easier.
Yeah.
Things like DesignWorks and Geomagic.
Oh, wow.
You're able to scan something, load it into one of these softwares, and it will already automatically sense the organic scan data, which is often very complex, and then model it into simpler surfaces. So that if you need to modify it, instead of modifying hundreds of thousands of tiny little triangles that make up what's called a mesh in a scan, then you're only modifying very simplistic faces at a time.
Exactly.
So your model changes to it that
And
way.
at Stacks 3D, you guys can do like full body models.
Yes.
Is that right?
Yeah, so that's a different technology we're using for that most of the time.
Okay.
While the EVA can be used to scan someone, you imagine you want to give a pose. You want to sit there for minutes at a time.
Yeah, exactly.
Yeah, you can to get a really high detail, but we have a photogrammetry booth. And photogrammetry works by having an array of cameras all around you. You step into the center, and it takes all of those photos simultaneously.
Oh,
right?
wow.
And software after that will take each perspective of the photo and stitch them together so you get a full 3D image.
Yeah.
Right?
So it's similar to like we did an episode on 360 video. It was our first episode.
Yeah.
And instead of having the cameras all pointed out, you just have them pointed in at a single object. Yeah.
Yes. So you can capture images instantaneously that
Yeah.
way. So whether it's people or we've often done pets actually, cats, dogs, birds, even babies.
Oh,
you just
wow.
need less than 1 second to capture that image, so that's why photogrammetry lends itself well.
Yeah.
Yeah.
That's really cool. So what other applications are there for 3D scanning? Is there any other?
Yeah, so you imagine the whole world is getting digitized, right? We were working with Pueblo Grande Museum to scan their artifacts so that they could 3D print in full color copies of those artifacts and have those on display where visitors can actually come and touch and feel things at scale instead of having to worry about the real relic being damaged and behind a glass case.
You could also, I imagine, scan an entire room. Like
Absolutely.
Go to rooms that are probably off limits, people for certain reasons, or environments that are off limits.
Right.
Scan that environment and create a room people can explore.
So you imagine all of the ruins out there. People want to make sure they're preserved as much as possible.
Yeah.
So before, after, during a dig, you might be able to go out there and use something called LiDAR scanning. So you have basically a laser go up and down and around 360. And it scans both color and depth of everything around it. And you get that point cloud data, all those little tiny, imagine the laser points as one tiny image, captures all of that. And then you can create a 3D model from it and use it for whatever purpose.
I bet like real estate probably is looking
Huge,
into that.
yeah. So we're working with some realtors right now and people that cater to realtors or home builders. We're 3D scanning houses and then printing the architecture, whether it's for marketing purposes or say the plumber needs to know where the electrician has been working on the floor above them. You can have that kind of visual cue very simply instead of looking at a lot of 2D diagrams and having to sift through that.
And also with the handheld scanner you were talking about earlier, you can also do something similar with your phone.
Right, 1, 2, 3D catch.
It's not as probably not nowhere near the quality.
Sure.
But if you have an object standing still, you can go around your phone and just take a picture from all angles.
I was just doing that yesterday. In fact, I was getting a haircut and I said, would you mind? I don't know how to explain all the time, how to say do this here, there. So I said did a before and after 1, 2, 3D catch so I can take it to the next
stand
time.
perfectly still.
And so you imagine you're sitting in a chair that might be able to be like this. The 1, 2, 3D catch application is free from Autodesk. You can download it. It'll instruct you once you download it how to take those pictures and move along. About 40 pictures or so. And then it will go out to the cloud. They'll resolve that image and spit you back out a 3D fully textured model.
Oh, wow. And you can also do this with like a camera. There's like software on the computer that can take photos and put it all together.
Right.
Yeah, and if you have like good amount, I'm imagining, then it can make a high quality render.
Exactly.
So yeah, so we can 1 second here. I think we're Okay, we're good. Okay, so our we probably had a little bit of audio issue, but I think we're fine. We're still streaming good, so and our audio bar is moving there, so it should be good. So let's go on. We're talking about 3D scanners. We already did that, so we're going to talk about the future of 3D printing.
Right.
So we already kind of talked about a little bit of what 3D printing is already doing. But there's a huge world of 3D printing down the line that's there. It's going to be a revolution. I mean, even you're saying that it's the next industrial revolution, as big as a light bulb or as the discovery of the internet.
Right.
And like some of the things that I've looked into that we can do is 3D printing houses.
Yeah.
I know that China right now is working on that. They've printed several houses. I think they even 3D printed a huge mansion using 3D printing technology.
Yeah.
Obviously, it's nowhere near the same as a 3D printer that used this guy. It's not a tiny little thing. It's massive, I would imagine. But that's pretty cool. And the fact that we could probably just, instead of building our houses, just design it digitally and then tell a 3D printer what to do.
Right. Yeah, you get to have that much more ability to choose. Here's my first floor. Here's my second floor layout. And then a printer will take that information and make it for you.
Yeah.
So when we're talking about future uses, it's actually astounding what is happening now. We were talking earlier that a lot of people aren't even aware yet of how advanced this technology is today.
Exactly.
Right? So we've talked about skin grafting, organ printing is actually happening now and being tested so that donors will no longer be the main source necessarily for organ transplants. You can actually grow it in a lab and implant it in that way with stem cells from the actual person.
Like bioprinting, right?
Yes, exactly.
Yeah.
Right. So we're actually about to enlist a company in Vision Tech who has a 3D bioplotter. So I'm very interested to work with local research communities to develop this technology and further applications in cancer research and things like this. Right. So there's already a crazy amount of advanced, whether it's aerospace, things that are going to the ISS, or it's being implanted in people or practicing surgery. And now we've got 3D printing of entire vehicles with companies like Local Motors, right? So Local Motors, as an example, we did, this is a small project we did with them. This is a little 3D printed keychain, but it's a model of Ollie, and Ollie is a fantastic project. Right, Ollie is something that has been 3D printed and has an autonomous brain. So it is driving itself all around town. Whether it's from Las Vegas, it's made its way from DC to Las Vegas, now it's going around the country and Local Motors is releasing it. So it can be something that we can repurpose as, a cafe on wheels that fits up to 12 people and is driving itself. You can call it like an Uber, or it can be a working gym or a meeting place. But this kind of technology is disruptive and revolutionizing the way that we interact with, cars, with public transportation, and how we have mass customization of catered needs. Like, I need public transportation.
Yeah.
Right?
Yeah, because I could imagine a future where self-driving cars are around, and so you just order a car and it comes and picks you up, and then the computer decides, there's not enough cars to populate everybody, so it prints more cars.
Exactly, right.
And just as a full automated system.
Yes.
But at that point, you're wondering, what do humans do anymore?
Right. You would like to think we're freeing up our minds for more complex things, maybe how to explore the deepest depths of the ocean, how to save the environment, how to explore space, and how to do it all, harmoniously.
Yeah, I think it's the same way with how Star Trek was. In the future, you could just have devices where you have anything you need gets 3D printed for you, whether it be food or whatever it be. There's a replicator there.
Yeah.
So I think that's really fascinating. I think there's so many possibilities there.
Right, and we start to talk about too implementing it with your own organic body. So whether it's prosthetics, or we're seeing a lot more people implant themselves with RFID tags. Yeah. And this kind of thing will keep going. We've seen people implant magnets into their fingertips so they can actually have a literal sixth sense and feel electricity coming from power sockets. Yeah. So we're going to see whether it's wearable or implanted. 3D technology is going to have a big role to play in both scanning, modeling, and printing. Yeah. In the realm of how are we going to manipulate our own genes, our own physical body, and how are we going to modify the way we think with programs modified in like augmented reality and virtual reality.
Exactly.
Yeah.
And I think this will become I think it's only probably a few years away, or maybe 5 years at the most, because once technology becomes cheaper, technology becomes easier to make.
Right.
We can start seeing it in more households.
Exactly.
And when you start seeing it in more households, people can start realizing what it's useful for.
Right.
I think right now a lot of people think of it just as artistic uses, like making art,
Right.
which is really good for and it's really cool for. But you could also 3D print a tool you needed for this instead
Absolutely.
of
I'm carrying around 3D printed items all the time. So my phone case,
3D
my
printed wallet,
carabiner, and I keep thinking of new ways. I have a 3D printer at home.
Yeah.
So I slowly will see my house turn into 3D printed items, whether it's a coat hanger, a key hook,
a cup.
Exactly. Whatever it may be, I don't necessarily have to go to the store or rely on someone else's design, or I can take their design and riff off of it to make something new and better or customized to my needs.
In my industry, like media, I always have since I'm low budget and I don't have the money to really go out and buy the $5,000 tripods. I have to custom build my tripods.
Exactly.
And so I always go to Home Depot and I always need these specific
Right.
screws and these specific things, and it's never available or they're always out.
Right.
And I can imagine a future where I'm just I need this. Go to my 3D printer and I print out that screw I need or whatever I need, and it's there for me.
Just happened the other day. I had my 3D printer and there was a leaky sink. I figured out it just needed a little extender connection, and I had some material that worked for it. So I just quickly measured it, modeled it, printed it, and within less than 2 hours, the sink was no longer leaking.
Oh, wow.
Right? So little things like this, you figure out, or once I've got your basic understanding of how to interface with technology, I can actually find more uses. And now I'm looking all the time at work. What can I make better, safer, stronger?
Exactly.
And you just let your mind play with that, and you help other people around the world figure it out, and you download their ideas.
Yeah. If a TV breaks, you can just print out a part you need. If it's some part that broke or a computer broke, you can just go to the store if you don't have a 3D printer yourself and go to Stacks 3D and get them to print a part.
Yes,
Exactly.
right. So if you've got something where you don't have a printer, whether it's at a library like this, Stacks 3D also print services, has many different materials and models available. And you've got a lot of options for solving real world problems of today in a very cheap and customized way.
And it's oftentimes cheaper than going online and finding a part, which you may never even find because they could stop manufacturing that TV or they don't manufacture the parts for it. So it's almost like with this, it's a step towards a different kind of market. You have a newer market approaching, and I think one hurdle that's going to be out there is kind of trying to convince society to accept that new market, because it means a lot of loss for big companies probably who will lose money that make little trinkets like keychains and stuff, will lose income, and even on a bigger scale. Because now that people can just 3D print those things. There's no reason to order it.
You hear about the economic disruption that 3D printing and 3D technologies in general offer. But much like everything, with the advent of computers and cell phones and the internet, you see an evolution. Everyone adapts to the way that the world evolves.
Yeah.
So we see this new technology. It's been out since the 80s, but now we're truly getting our hands on it as everyday Joe and Jane and being able to interface with it in an easy way, so that we can then not have to go to the store or make something that is specifically suited for us, and we'll make it better for everyone in the end, because more brains are better than just one working on a project.
Exactly.
So this whole crowdsourcing, people like Local Motors have really tapped into the potential of additive manufacturing and crowdsourcing. So they'll have design challenges where they'll say, here are the open source 3D plans for a vehicle we have.
Yeah.
We challenge you to come up with, for instance, adding drone technology to an autonomous vehicle. How do those things interplay? And then someone will design it.
Yeah.
And then we'll print a prototype of it to have a concept model. And then if it's popular enough, these will become real things.
Yeah.
So much like we saw in Star Trek, flip phones. We see Dick Tracy with his video watch, and now we have these things in real life.
Yeah.
Science fiction starts that way because it can't be made just yet.
Exactly.
Right? But it is the nature of an idea to evolve, and then when we have the means and the creativity and we're empowered to act on it, we can make incredible things.
Yeah, and if you it's incredible to think about all these technologies combined, and just the fact that our future could be completely different. Because it's like getting someone from the 1800s and trying to make them think of our time right now,
Right, yeah.
they wouldn't be able to imagine it.
Exactly.
It's that kind of mind-blowing thought.
Yes.
And that's the kind of thing that I want to deliver to my audience,
Yeah.
is that kind of thought-provoking thinking, is that the future is not the way we are right now.
Yeah.
The future is a whole different market, a whole different society, with no limitations or
Right?
you
You're
know.
going to be able to say, I need something or I
Yeah.
want something. And if you're willing to go about the process of learning how you intuitively interact with matter and ideas, you can use a method like this to bring your ideas to life.
Yeah.
Right? And you can work with other people to expand those ideas and share them with a global society, because that's what
Exactly.
we become. Right? This information is no longer just in my city, in my state. When I can release a model onto the internet, it will be global in a second.
Yeah.
And then anyone can use it and riff off of it. So with the advent of things like crowdsourcing through the internet and 3D technologies to actually bring ideas to life,
Exactly.
I think we are going to see the next industrial revolution.
Yeah. And it's like a hypothetical situation. You could be someone, let's say you want a new desk, customized desk. You could scan the desk, then you could put on some VR glasses,
Right.
design your desk, move it in a
Exactly,
3R
right,
environment,
Yeah.
and then you could change it, move it around, and send it to a 3D, just like squash it over,
Exactly like
3D
when you're on the
printer,
airport. Yeah.
and then it comes out of your wall or whatever.
That we're not that far, honestly.
Yeah.
At work, sometimes that's what it feels like.
Yeah.
'Cause, at one point we're saying, "Hey, we need this thing." It's probably just faster for us to make it. So
Yeah, exactly.
we'll say, "Okay, let me go to the computer for a minute, and then I'll model it up, make
Yeah.
sure it tests right. Okay, cool. Let's print off 6 more that we need, and then we've got it implemented in the same day we thought that we had a need for it."
Yeah, yeah, because like I think it's I lost my train of thought, but I just think that's so cool, and I think with because you guys actually I was gonna say you guys do VR too, don't you, on your website? I was reading that.
Virtual and augmented reality. One
Okay.
of the most interesting applications we're currently working with, the Cummings Institute, a behavioral health institute. We had amazing people over there working on incredible projects for the good of people, right? One of those projects we were collaborating on is using VR technology like Google Cardboard glasses that we sell to be able to use your phone, tap into, for example, post-traumatic stress disorder. Those with that might benefit from having an environment that is calming. So you have earphones and then you have a visual display that kind of brings you to your happy place of sorts.
Yeah.
And that allows you to, whether or not you need medication, whether it's with it or without it, you're able to have this place that can hopefully bring you back to a calm state.
Exactly.
Right.
And Pure Genius did that too in their first episode.
Yeah.
And also, if you want to know more about VR and 360 video, watch our first episode.
Yeah, good
We
videos.
go over that in kind of the same way we did here. I did an expert. We did a video chat expert with someone else in another place, and he talked about 360 video.
Yeah, so we've got like HoloLens, Microsoft
Yeah.
HoloLens at work right now. And people that get tours over there, we show them every time. And we have this discourse of, for instance, we talk to some people in the local fashion industry. And we say, imagine, you put these on, you work together in a collaborative community, which is what we're all about, establishing the means to work together with high-end technology. You have this virtual environment, augmented reality. You've got the ability to 3D model, and someone's designing a dress or a shirt or a tie.
Yeah.
They share the 3D model, everyone can see it virtually. Then you say, how about this pattern? And
Yeah.
you're doing gesture-based or voice recognition, and you're actually modifying something on the fly collaboratively, and within the span of an hour, what could have taken a week through traditional email communications and file swapping and different softwares, you've now condensed that collaboration to a very tight-knit group and timeline. So that you're producing things more customized, faster, better, cheaper, stronger, and in every way it's going to revolutionize the way we work together.
Yeah, then if you had like a friend in Europe and you had like the object he needed, a solid object, you could just 3D print it to him.
Yeah, let me scan that. Hey, I'm going to send you a pumpkin here in a second.
Yeah, exactly. Just like the Olo app lets you kind of do kind of right now. And we were talking about earlier off camera that's currently kickstarting.
Yeah.
And we're not sure how reliable it's going to be.
Yeah, we'll see.
But that technology is still something that could exist in the future where you could
Absolutely,
just send your friend a gift for Christmas, and they just 3D print it with their phone and a little device.
Right. Let me send you an actual physical grumpy cat.
Yeah,
So,
exactly.
Whether it's something like, hey, I have a test model of a prosthetic fingertip that you should try, or it's something novelty. this is really going to help us share with each other and equalize access to information and objects.
Yeah.
And I think that's going to put us on an even playing field.
Exactly.
It's going to really change the world for the
And
better.
I think it's a matter of, I think like in testing at least, the future is here now. It's just a matter of getting it to the rest of the people.
Right.
And bringing it out to the world.
Yeah, and so we've really focused on that aspect, is trying to bring this information in a very simple to understand, and face-to-face interaction is important with this stuff a lot of the time.
Yeah.
You can buy a 3D printer on Amazon, you get it to your front door, and if you're not the tinkering type, it might take you days, weeks, certainly hours to get something out of it if it's even good.
Exactly.
So that's part of the reason Stacks 3D started. With the two owners, Jason and Elisa Yoakum, they found a need of being able to interface with this technology in person.
Yeah.
And much like here at the Think Space with the 3D printing classes, and over at Stacks where we have people come in and learn about this technology and demonstrate it and have them use it.
Yeah.
Once you're able to get your hands dirty, the fear and the uncertainty is taken away, and then you're empowered to actually go forth and make your ideas.
Yeah, I read online on your website that his wife was an artist and he was an
Yes.
engineer,
Right.
and they were like, what better way to combine the two fields?
Exactly, right? You got the science and the arts, and they really work well together
Yeah.
in a creative capacity. So, we hear a lot about STEAM curriculum, STEM curriculum with A now arts. It's very important to kind of meld these interdisciplinary practices and get high-end technologies into classrooms as early as possible,
Yeah.
so that we can equip the youth and therefore the rest of the society with the ability to make these ideas happen.
Yeah.
And we're going to see, an explosion.
Can you talk for a moment about how much like your wallet costs to print and how much your phone case costs to print? Like people wanted to have this.
So obviously there's a price if you get it through
Yeah.
print services, which is different, but owning your own printer, incredible. So if I was to say my phone case, my wallet, my keychain, all calculated into material cost, I would say still less than $5.
Okay. So if I go to Stacks, could I get them to print a phone case for
Right,
me?
you give us a file, whether it's thingiverse.com or Umagine or My Mini Factory. There are many websites out there. If you're
Okay.
searching for 3D files to download. You can send us a link, you can call us up, send it through our website, whatever method is best for you. Or you can say, I've created something myself and I'd like you guys to make it.
Okay.
And we'll give you tips if it's already ready to be 3D printed or if it might need to be modified for better printability.
Okay, so I have this 2D logo of my Qonda character. You may
Yes.
have seen it.
Yes.
How can I? Is there I guess I could use a design program, probably just do an oval. I don't know. Is there like a really good method for me to turn it
Yeah.
into a 3D printed object?
Well,
Or
we do that all the time. It's called
Yeah.
2D to 3D.
Yeah.
So there's a couple different ways. If you want a character's face to be rounded like Olaf's here, that's a different method.
okay.
You're going to have to combine different shapes like cones and spheres and hemispheres.
Yeah.
If you want it to just simply be, you've got a top-down view of your character, you trace over the major lines of him and you extrude them or you pop them out,
Yeah.
that's one way to do it as well. That's very
Okay.
simple, right? So either way, it just depends on what you personally like as the style of the 3D version of your logo.
Okay.
And we can find a way to make it.
Okay. And then also, your company this Christmas has some specials going on.
Yes.
You mentioned that.
Yeah, very cool. We just finished the a holiday special for Halloween where we did little pumpkin figures. But what we've got going on for Christmas season is it's called Taking an Elfie.
Okay.
Right? We have an elf prefab character, so it's pre-made, and then we scan your head to put it into this character.
Yeah.
So I've got one of myself, and we put it in a little clear ornament you can hang on the tree. So
Oh,
you
that's
have
cool.
yourself and the whole family in the tree, and I might even do the dog this year. We'll see. That's something
Yeah.
a little strange.
Nice. Okay, so we're gonna go on to the Q&A portion of the show. So here we are. Throughout the show, we did get some concerns that audio may have been not working, but I am recording this. So if anything is going wrong with the live stream, I'll upload a better quality version down the line. And we'll make sure that gets fixed. But we'll just keep moving with that. So we have some questions. We have our behind the scenes guy who gets referred to as Tails. Tails is going to read off some questions for us.
Hey, how's it going, guys? So we got Gus Lando. He says, can you print things like mechanical gears for like individual projects?
Oh, that's a good question.
Right. Yeah, we've been doing a lot with reverse engineering FRC robots, first robotics competitions. So whether it's just a standalone gear, that's simple enough, or it's actually interlocking gears. There's different printing technologies that allow themselves to do that very well. For instance, over at Stacks we have what's called a ProJet 3510 HD Max, and it prints with plastic material that is hardened by light, and it also, as a support material, uses wax. So imagine you have like a planetary gear system with all interlocking parts. You
Yeah.
can print it in a static way with a bunch of wax supports, and then you can melt out that wax supports in an oven so that once you get it back, it's a free use gear system.
Yeah.
So you can actually have a working interlocking gear system straight out of a 3D printer.
Oh,
But
whoa.
what you'll figure out is there are certain printers that are better to do that,
Mm.
and also better materials that can withstand a lot of force that gears sometimes
Yeah,
do.
exactly.
Right?
And also, I should have brought it for demonstration, but the library has an example of like a little elephant and its feet move.
Yes.
So that's like a very
Right.
simplistic version of that, where you have a little bit of movement
Some
there.
movements. And
Yeah.
laser cutting, they call it kerfing.
Yeah.
And sometimes also, if you look at the inside of an acoustic guitar, it has it all around the inside of a body.
Yeah.
But if you have some material and you chop into it, but not all the way through it,
Yeah.
if you do that enough in tight intervals, it'll allow itself to bend where it once was rigid.
Yeah.
Similar fashion, if you're 3D printing something, and then you actually have subtract material out of it, or you model it to have those stripes, then it will be more flexible. right?
Exactly.
Yeah.
That's really cool. Tails, is there any other questions?
Yes, Brandon Ross says, what is the average time to complete a project? For example, a car.
Ooh, good
Yeah.
question. So if you're doing a full-scale car like Local Motors does, once they've got everything tuned in, the machine's working just fine, it takes them somewhere between usually 2 to 4 days depending on the size of the car. And they're not usually printing the entire car all in one go. They're printing sections of the chassis at one time.
Okay.
So whether it's an entire side panel,
Hmm.
it's still a giant chunk of the car at one time.
Yeah.
And the material they're using is also very strong. It's
Okay.
part carbon fiber and part ABS. So
Yeah.
I had the opportunity to actually ride around in this, and
Oh,
we
wow.
3D scanned 2 of their vehicles and made
Yeah.
little full-scale or small-scale full-color replicas. And the material they make it out of, this thing feels like a cannonball on wheels, except it's super lightweight.
Oh, wow.
And so they pack in an electronic motor into these, so it's sustainable as well as it is very zippy.
And it's definitely cheaper and faster than the original method, or are they still improving
It
on
depends. I mean, so for instance, the street legal one you can buy now is roughly $40,000.
it? Okay.
And you can go and ask them to build it custom for you depending on what you need.
Yeah.
And that might have a different price. But what you're going to see is the more people that implement this, the more micro factories that are going to pop up like Local Motors. And they're
Exactly.
also expanding as well, so that, imagine in Chandler, they have a facility.
Mm.
So I can say right now, hey, I'd love if you 3D printed me a custom vehicle.
Yeah.
Let's modify this current design to be, I like to go surfing, so let's make it all about surfing.
Yeah.
And they actually have a car that's already geared towards that. It's called the Swim.
Oh, that's cool.
So it's fantastic. They have flexibility to adapt to requests. And I think that's where you're going to see a lot of manufacturing head towards.
Yeah.
Custom and small batch uses.
And with I'd imagine with like an electrical car,
Mhm.
or like back in the day when California was trying to get hype on the hydrogen cars,
Yes, right.
they were marketing that you could just exchange your
Your batteries.
well, no, your the
Oh, yeah.
shell of the car. You could
Right.
you could just keep the engine
Yeah.
and the everything else and just move the shell.
Pop it into a new
and get a
look.
new one. Yeah.
Right. Kind of like when you lease a car, you might want to change it out after so long.
Yeah.
But yeah, with this kind of technology, you could say, maybe I want a new style of bumper this time,
Mm.
or a new upgraded version that's safer has come out.
Yeah.
And just implement like you do a transplant system. So you're never replacing an
Exactly.
entire vehicle, and a lot of the time it's much easier than buying what's often overpriced in fiberglass or the traditional.
Yeah. So how long does it take to print like your phone case or this pumpkin or something?
So to give you some frame of reference, also different printers, different speeds,
Yeah, exactly.
right? And different technologies, different speeds. So we could print something like this phone case in about 3 hours or so.
Okay.
Something like this pumpkin. It also depends on the
Yeah.
settings you have, but
Yeah.
by the looks of this, probably about 4 to 8 hours, somewhere in there.
Yeah, because this one was printed at the library, so you
Mhm,
probably
So settings like infill and
Yeah.
resolution have a lot to play
exactly.
into the time it takes to
I know
print
this
something.
one took about 2 hours. When I did the time lapse, my camera took 3,000 photos 3 seconds apart.
Yeah, right?
Yeah.
And so you modify this by telling it how thick should every layer be.
Yeah.
The thicker they are, the less time it takes and the less material you're using.
Yeah.
Right? But also the rougher the edges are going to be, kind of like a step ladder.
Okay.
But the smoother it is, the lower your resolution. So then he usually
Mhm.
measures this in microns, like 100 microns or 0.1 millimeters.
Yeah.
So this probably is 0.2 millimeters or 0.1 because it's relatively smooth.
Mm.
So if you want it to look smoother, it will take longer and use a little bit more material.
Yeah. Yeah. The library has 2 printers. The MakerBot 2 and the MakerBot 5.
Mhm.
And the MakerBot 5, I know, people telling me that it prints slower but at a higher quality. and then they make about 2 prints faster, but a little bit low resolution.
Yeah, you'll find each one suited for it. Sometimes they have specific uses, like Formlabs, which is Form 2 has an SLA printer, different type of technology, not plastic. It's resin based and then hardened with ultraviolet light lasers.
Okay.
Right. That has incredibly smooth surfaces, so it can do much smoother than this.
Yeah, because this is kind of rough.
Right.
If you
so
can
imagine
feel it.
this is 100 micron resolution. Every layer is 0.1 millimeters thick.
Yeah.
And then with SLA technology, you get much finer with that. For instance, 25 microns on the Form 2. So you effectively stop being able to see the layer lines at that point. And it's very good if you're trying to do something, for instance, in stop motion animation. People are using the Form 2 to print out characters, and then they'll paint them up however they need and use each little pose in their stop motion animation.
Yeah.
You can get very crisp and clean that way.
Huh, that's really cool.
Or jewelry.
Do we have any more questions, Tails?
Yeah, we have 2 questions that are fairly similar. First, what is the most expensive order that you've had placed, and also what's the largest object that you have printed at your factory?
That's good questions.
Yeah.
Probably, one of the more notable larger objects was an experimental surgical device we did last year, which was meant to actually pop hip bones out of people during surgery.
Huh.
So it was about almost 2 feet tall,
Yeah.
and it was all one piece. So you had to be able to use this, and it kind of looks like that game where you're at the beach and you have the ball and you're tossing it.
Okay.
It has a system where a doctor can hold it and cover it in surgery, and then they'll use it, and with the small flexibility and the angle and the geometry of it, it allows them to do that kind of operation better than they could before.
Oh, wow.
So that's one of the cool larger ones we've done.
Yeah.
And as far as one of the most expensive ones we've ever done, it depends, because there's one unit expense, and then we've made 75 of the same thing, and that's been an expense. So an example would be we made 75 satellite models for both Orbital and NASA.
Okay.
So we're working with those companies to produce small-scale models of real satellites that are given to the design team as awards.
Yeah.
So people that worked on it and might be notable in the company are able to be given these and receive them.
Okay. My dad's a satellite engineer, so
Awesome. So was the CEO.
Yeah.
He used to work at Orbital, so he's been in aerospace, and we learned a lot. He's had much experience in 3D technologies and has watched 3D printing evolve since the 80s.
Oh, wow.
And got to meet Chuck Hull, the inventor of SLA technology. So we get to have a lot of good background experience, and when we do our projects, we're able to pull from well over 30 years of combined experience in 3D technologies to figure out the best method and materials.
Oh, wow, that's cool. Are there any other questions, Tails?
Yeah, just a couple more now.
Okay.
Wow, this one's really deep. Could you use the printer to make enormous objects like planes or tanks for military use, and have you done so?
Well, I was talking about before, China printed a mansion using the 3D printer.
Right. So personally, ourselves, we're not in the habit of doing huge scale 3D printing. Right.
Yeah.
We are looking at it, and we're also looking at partners for it. So one of those companies is called Delta Wasp. They have both desktop level printers and then larger format for like sculptures.
Yeah.
And then they have entire 60-foot tall versions that actually. This is a really interesting group that uses natural sand in an environment and a proprietary binding agent, so they can go into the beach somewhere, use the natural environment, and then print homes.
Oh,
so you can imagine the implications if we sent this thing out to third world developing countries,
Yeah.
and people and organizations were able to do this in a sustainable manner, using the real world elements there, so that they could produce it in a way that made sense for that environment and was efficient.
Well, this could have like I'm sure the military's on top of this, because this could have a really intense military application.
Yeah.
You could just have a 3D printer on the battlefield,
Oh, yeah.
and you could print out like titanium or carbon fiber tanks.
Whatever you need,
just coming out.
You're talking, a lot of the drone or UAV industry is using 3D technologies all the time. It's pretty much the standard. You're able to rapid prototype better aerodynamic designs very quickly, throw it in the wind tunnel, crash it as many times as you need to, and then print off replacement pieces.
Yeah, exactly.
Until you find your final form.
Could you if like you saying it broke it? Could they take that material and like reprint it, or because
that is one option.
Is it
For instance,
reusable?
with local motors, that is in fact what they do. If they have scraps or something that didn't work quite as well as they wanted it to, you can grind it back down, melt it back, and then spool it back out.
Yeah.
Right. And that's true to the main types of printing materials like PLA and ABS too. You just need the materials, the machine that actually does that.
Yeah.
And it's not that expensive.
Okay.
You're talking less than $2,000 for the full setup.
Okay, cool. Tails, do you have any more questions? We have 5 more minutes.
Actually, that's just fine because we have one
Yeah.
last question.
Okay.
Like chat's been pretty silent. So if you can print all these things, what really is the limit? Have you pushed it?
Right. A lot of the time, I would just say your imagination, honestly.
Mm-hmm.
There is not something you can't do. So if you think, could I 3D print blank?
Yeah.
While I couldn't necessarily say, yep, here's the printer, here's the material, and we'll do it for X amount of dollars.
Yeah.
You know, we talk to different research facilities, and they'll come to us and say, can you do blank? We'll say, well, not yet, right? So you
Yeah.
figure out, here's the closest I can come to it, and then here's where we need to get to. And then you just start prototyping along the way. You figure out, how do I get closer and closer to that intended output? And along the way, you'll always have happy accidents where you might discover something you didn't intend that might have benefits that far exceed what you were trying to do. So this kind of experimentation and the DIY community is incredibly driving force to this kind of effort.
Yeah.
So you're going to see all the way on up from the highest military procedures to me and you in our garages being able to interface with this technology, and what you and I can do can revolutionize the world just as much as what someone with trillions of dollars can do.
Yeah, exactly. And I imagine like the biggest limitations to the common Joe right now is scale. It's just like, the 3D printers right now that are affordable are still small,
Right.
and they don't print that big. And so it's just a matter of like, getting those 3D printers bigger and that cost down for
Right.
for
So,
bigger
to some
printers.
degree, you can imagine you might not have to have the full scale to present an
Oh,
idea.
and,
and
like,
understand
piece it
right?
together, yeah.
I can print the Eiffel Tower, and if I'm trying to make a modification or a design inspired by it, I can pitch it with
Okay.
scale models.
Okay.
So that's common in architecture, right? People
Yeah.
come with plans to build something in Phoenix, they 3D print a model through us,
Mm.
and then they can get $60 million to go and build that.
Huh.
So they'll present it in that way. So scale isn't always a limiting factor.
Yeah.
I like to say with $2,000, you can easily do something that will change the world. You
Yeah.
don't even have to have a dollar to do it. You just have to have an idea and the willingness to follow through and explore
Exactly.
it. And that's what we're here for. We're
Yeah.
trying to help educate and empower the public so that they can really get a grip on how to bring their ideas to life.
Can you even like print out pieces of something and then build it together?
Oh, yeah, absolutely. That's very common.
Yeah.
If you need something to be big, and we commonly do this, you'll figure out a good way to section it out
Yeah.
and then fuse it back together, whether it's just glue and adhesives or it's like embedded nuts and bolts
Yeah.
you're putting together. There's a lot of different ways, and if you want some assistance, that's something we'll help consult with.
Yeah, that's really cool. Okay. Well, is there any last words you have for us, Chris, before we go?
Well, I'd just like to say thank you for the opportunity of being here today. I really appreciate nothing more than helping people do what they love for a living. So I think I connect a lot with Stacks 3D, and that's why I work there. We're trying to establish collaborative communities and really bring the world together to implement 3D technologies and use it to its fullest potential. So I think we're at the inception of a new industrial revolution that will hopefully create a happier and healthier world.
Yeah. Thank you for joining us.
Absolutely. Thank you.
Yeah. Thank you so much.
Yes.
It's been a great show. Okay, we're gonna close out here. So thank you for joining us. We'll see you next time. This has been the Q&A Tech School, coming to you from the ThinkSpot on 3D printing. Again, it's presented by Qonda Entertainment. Next week, I'm doing a tutorial on Premiere Pro. So if you're interested in learning some video editing, watch that on Thursday at 11 a.m. Wednesday, I'm also doing a class here at the ThinkSpot on Final Cut Pro. It's part 2 of our class. Watch every Thursday at 11 a.m. and Fridays at 3 p.m. We'll probably stop Fridays eventually. We're on YouTube, of course, and we're on Facebook, we're on Twitter, and sometimes I upload these podcasts to SoundCloud, so you can listen to them as audio only on the go. SoundCloud gives you a limited amount of space though, so I'm trying to work that out. But that's an option too down the line. And then submit your questions even after the show, and I'll get to them. Thank you for joining us.